Hello everyone. In today's session, we are going to discuss some of the examples for context-free grammar representation. See, whenever you want to follow some syntactic structure, the syntactic structure rules and regulation can be given in terms of a context-free grammar. Okay, so in this video, I'll show you some of the programming constraint and how a context-free grammar can be used to represent those programming constraints. For example, I'll take a declarative statement or a if then else statement or a conditional statement, and I'll show you how operator can be like how a context-free grammar can be constructed for those. Okay, so first I'll take this declarative statement. How come you write a declarative statement? It varies from programming language to another programming language. Okay, a declarative statement, in case of like I take very simple examples alone. So in declarative statement for a C program will look like this. Okay, you have a data type followed by some set of identifiers, end with a semicolon. So this is how we write a declarative statement in case of a C program, right? So the grammatical structure for this or a syntax structure for this can be given as declaration tends to you have a type. So all those all those places of your declarative statement, it starts with a type. So I can give type. So you have a type, and this type might be either integer or floating point or character. I just take very simple example. Okay, a normal, I don't go ahead with an array or other kind of declarative statement. Just a normal declarative statement with either integer, floating point or a character, and I'll show you how does the grammar will look like. Okay, so it starts with a type, and the type might be either integer, floating point or a character, and it followed by some list of elements, like list of identifiers. Okay, so you have a list. Okay, and I'll show you how this list can be expanded, and it end with a semicolon. Okay, so all these things are mandatory. A declarative statement starts with a type followed by some list of identifiers, end with a semicolon. Okay, so this is how we write a grammatical structure. And again, type might take either integer or floating point or character. So to represent or, we use the slash operator. And finally, you have some list of entities, right? So list of identifier, and even a single identifier is also allowed. This is also allowed in case of your declarative statement. So what we can do here is a single identifier, or I can have any number of identifiers separated using comma. So this is a recursive procedure, right? So I can write it as id comma again a list, and this list can be expanded as any number of identifiers. Okay, so wherever you have this more possibility, we call a recursive function here. So I either a single identifier or identifier comma list. Okay, so this is how we write the grammar, context-free grammar for any statements. Okay, and how can you explain your tuple notation? We have 4 tuples, right? Variable, terminal, starting symbol, and production rules. So what are the variables we have here? What is a variable here? Variable is something that is written in this side that has a definition. Okay, so here your variables are declaration, type, and list. Okay, so these are all your variables. And what is a terminal symbol? Terminal symbol is something that comes in your input. So in this side, in the definition side, other than your type, list, whatever you have, those will be your terminal symbol. Okay, and leave this slash. Slash is like an operator. It is a separator. Okay, so what all you have in the first statement, we have type. Type is a variable. List is a variable, and you have a semicolon. Semicolon is not a variable, so it is a terminal symbol. And here you have integer, floating, character. Everything comes in your input, right? Int, float, or character. So all these things are terminal symbol. And here you have id. Id is a terminal symbol, and you have this operator called comma. Comma is also a terminal symbol. Okay, so now you got a difference between what is a variable and what is a terminal symbol, right? Variable is something that is written in the side that has an expansion for it. Okay, so that can be substituted with some entity. And terminal symbols are the one that comes in your input. So in this place, other than your variable, whatever you have, that will be your terminal symbol. And please don't include slash. Okay, slash indicates either this or that. Okay, and what is S? S is the starting symbol. So here your S is your declaration statement. Okay, so S is equal to declaration, the variable where the production rules actually starts. So that is called declaration. And finally you have production rule. All these things are your production rule. Okay, so this is how we define a context-free grammar. I'll show you one more example, like a statement. When you consider an if then else statement, your statement starts with if is a keyword followed by a condition, okay, and you have then other statement. Okay, so if condition then statement, or if condition then statement else statement. Okay, so this is how if then else can be represented, right? Either if condition then statement, or if condition then statement else statement. So that is also there. Okay, and if I want to include while statement, while statement will look like this: while condition then, you don't have then here, while condition statement you have, while condition followed by statement. Okay, so this is how a statement can be represented, and you have any number of statements here. Okay, you might have a declaration statement or assignment statement and something. So I just use epsilon as a stopping point. Like we cannot write all possible conditions over here, right? So for example, I just have if condition, if then else, and your while condition alone for showing you how your context-free grammar will look like. Okay, so statement is expanded as if condition then statement, or if condition then statement else statement, while condition statement, okay, or epsilon. And now I have to expand this condition, right? So there should be a way to represent this condition. Okay, and statement already is defined. And how can you define a condition here? Here your condition will be all Boolean operator, right? Your result should be either 0 or 1. If you have some comparison and based on the result you take either the decision. Even for while you have the Boolean representation. So you have to use all your relational operator. So condition can be expanded as identifier, to identifier, some relational operator will be given over here. Okay, or a single identifier. If it is just 0 or 1, we can use a single identifier to represent it. So condition here is based on two, like you can have your operation like this: if a greater than or equal to b. Okay, if a equal to b, then do this. So this is how we write a condition, right? So similarly, your condition will have either id, some relational operator followed by another identifier, or a single identifier. Now what will be there in your relational operator? Either greater than or equal to, or less than or equal to, or double equal to, or not equal to. So these are all the possible relational operator we can have. Okay, so this is how we can write a grammar for any of your programming constraint. Wherever you have a syntactic structure, that can be put up into a context-free grammar representation. Got it? Now list all the variables here, dear. What all the variables? The thing that is written in the side that has a definition. So what all is written here? It is a statement, condition, relational operator. So these are all your variables. And what is a terminal symbol? A terminal symbol is one that is there in the body of the production other than your variables. So what all we have here? You have if, condition is a variable, and you have then, statement is a variable, and you have if, then is written, you have else here. So else is a terminal symbol, and here you have while. Condition is a variable, statement is a variable, and you have epsilon. Okay, and here you have id. Okay, mostly we ignore this epsilon here. And you have relational operator. Relational operator is a variable, and id is written, and here you have less than or equal to, greater than or equal to, double equal to, not equal to. So all these things are your terminal symbol. Okay, so anything that comes into this definition of variable that is not included in your variable is called your terminal symbol. Okay, and what else? S is your starting symbol. So here S is equal to STMT. Your statement is the starting place of it. So you call it as STMT. And what is your production? These are all your rule for production. You can write it like this. Okay, so this is how we define a context-free grammar. I'll give you one more example. When you are writing your expression, and expression might be a infix expression, postfix, or a prefix expression. So what is an infix here? Infix expression can be written as a plus b, or a star b, or something like this, right? So the production rule can be given as expression tends to, you can add to expression, or multiply to expression, or subtract to expression, or expression can take one single identifier. You can go ahead with it, division, modulo operator, anything you can include here. Okay, and followed by one single identifier. So this can be replaced with the identifier, this can be replaced with the identifier too. So this is your infix expression. And what is a postfix expression? A postfix expression is something that has your operator comes at the back. Okay, so how can you write your your context free grammar for it? Expression consists of two expression added with it, or two expression multiplied, or two expression subtracted, or it can be replaced with identifier. Okay, just we are going to add this, like infix is something where your operator comes in between, and postfix is something that comes after your expression. And what will be your prefix then? Prefix is when you have your operator first followed by your identifiers. Okay, so this is how we write a context free grammar. Okay, so there is no standard rule like you have to use this name as a variable name or something. It is like declaring a variable in your programming. Okay, always give some valid names when you are writing a context free grammar structures. Okay, thank you.